Hi everybody, in this video I'm going to go over APEX section 7.3.1 study, which goes over gas properties. So this is a pretty short APEX section, so I'm only giving you one day to go through it, and I'm only making one video. Okay, let's get started. So this is talking about gas properties, and one of the major properties of gases is pressure. And pressure is the result of the force that gas molecules colliding with the walls of their container exert. So what I mean by that is if this is my container and I have some gas particles, we know gas particles are moving. They're moving rapidly. So at some point, they're going to bump into the wall of the container, and that's going to exert a force, and we call that pressure. Okay? This is a really important property of gases that's going to affect a lot of different things. Second thing we want to talk about is diffusion. So what diffusion means is if you have a container with two different gases that are separated, like this, okay? What's going to happen is if you remove that barrier, if you get rid of this, then these gas molecules are just going to start to spread out. They're going to go from a higher concentration to a lower concentration. So these green gas particles are going to go from a high concentration of green to a low concentration of green, which is going to make them move this way. The red molecules are going to go from a high concentration of red to a low concentration of red, which will make it go this way. And eventually it'll disperse so that they're all evenly spread out, and your result will look something like this. Right? So it's all evenly spread out. And that's just called diffusion, that these gas particles spread out evenly amongst each other. That's why if you spray perfume on one side of a room, after a couple seconds you'll be able to smell it on the other side of the room because those gas molecules from the perfume have sort of spread out through the air and evenly dispersed themselves. Okay, then we're going to start talking a little bit about phenomenon. So we talk about if you decrease the atmospheric pressure, a liquid will boil at a lower temperature because it's easier for the vapor pressure to equal the atmospheric pressure. Let's look at this a little more closely. So if this is our pot of water, right? We said that the water boils when the vapor pressure of the bubbles, the pressure inside the bubbles, is equal to the atmospheric pressure. So atmospheric pressure usually is 1 atmosphere, okay? Which means these bubbles have to get to 1 atmosphere and then the pot boils. But if you live on the top of a mountain, there is less air pressure, okay? So that means that, let's say the air pressure is about 0.9 atm. Now the bubbles in your water only need to get to 0.9 atm in order for the water to boil. So that's going to be easier than 1 atmosphere. So this is going to boil at a lower temperature. So if there is lower pressure, it's going to boil at a lower temperature. If it's higher pressure, it's going to boil at a higher temperature. And that's just because it's easier for the vapor pressure to be equal to the atmospheric pressure if it's lower. Great. Okay, so now I'm going to go over what you just did in your PhET simulation lab. This is talking about these 4 different properties of gases and how they affect each other. So the 4 properties of gases are volume, temperature, pressure, and number of particles. And first we're going to look at how they are affected by how they affect pressure. So if you increase temperature while holding everything else constant, hold the particles, hold the volume constant, you should have seen that the pressure increases. And if you decrease the temperature, you should have seen that the pressure decreases. So why is this? Okay, well, if you increase your temperature, I'm putting T for temperature, that means your gas particles are going to move more. And so they're going to collide more. which gives you a higher pressure. Right? So when I'm thinking about pressure, I like to think about collisions, right? Because pressure is indicated by the number of collisions. The more collisions you have, the higher the pressure is. So a good way to think about this is if you had a bunch of people walking down a hallway, how many collisions would they have? Right? So if you had a low temperature, your gases are moving pretty slowly. They're not going to bump into each other as much, right? That's like if everyone was walking down the hallway. But if your temperature is higher, the particles are moving faster, so they're more likely to collide with each other, right? That's like if everyone was running down the hallway, they'd be more likely to collide. So higher temperature means higher pressure, more collisions. Let's go to volume. If you increase the volume while holding the temperature and particles constant, then your pressure is going to decrease. If you decrease your volume while holding your temperature and particles constant, your pressure is going to increase. So why is this? Well, if you have a greater volume, increase V, there is more room for these particles, so they're less likely to collide. Okay, so if you have a little tiny container, then these particles are more likely to bump into each other and to the sides of the container. If you have a big container, they're less likely to bump into each other and to the sides of the container, right? That's like if your hallway was wider, you're less likely to collide into other students than if your hallway was narrower, okay? So increasing volume decreases the pressure. Let's move on to the number of particles. So if you increase the number of particles while holding the temperature and volume constant, you're going to get an increase in pressure. If you decrease the number of particles while holding the temperature and volume constant, you're going to get a decrease in pressure. So this is like if you were to add more students walking down the hallway, right? So if you increase the number of particles, and I'm going to put N for number of particles, they're more likely to collide. Okay, so if you have a container and you only have a couple particles, they're not that likely to collide with the walls or with each other. But if you have the same container with a whole bunch of particles, they're very likely to collide with each other and with the walls. That's like if you only have one student walking down the hall during a class, there's less likely to collide with another student, or if you only have two. But if you have everybody going between classes, there's tons of students, they're more likely to collide with each other. So an increase in the number of particles increases the pressure. We always think of pressure in terms of these collisions. The last part here I want to talk about is let's hold pressure constant and talk about temperature and volume, okay? So if we hold our pressure constant, that means we need to be in some sort of flexible container, like a balloon, not like a hard steel container. So if you increase the temperature while you hold your pressure constant and you keep the number of particles the same, the volume is going to increase. If you decrease the temperature while holding the pressure constant and keeping the particles the same, the volume is going to decrease. Okay? So why is this? Well, if you increase the temperature, that means your particles move more. Okay? So they are going to collide with the sides more. But we said the sides can move, right? They're not stiff. So that means your volume is going to expand. So for example, if you had a balloon, okay, that had some gas particles in it, these gas particles are going to start pushing on the sides of the balloon as you increase the temperature because they're moving more. And as a result, your balloon is going to get bigger. Okay? So when you increase the temperature, It's going to increase the volume, right? So that's why if you leave a soccer ball out overnight, the temperature is going to decrease. So they're going to push less hard. The gas molecules are pushing less hard on the sides of the soccer ball. So that's why it deflates if you leave it out overnight. Okay? So we need to understand how all of these properties of gases depend on each other and affect each other. The very last thing I want us to know is how a barometer works. So a barometer measures pressure. And the way it does that, let's just say measures pressure, is it has this tube of mercury that's sitting in a pool of mercury. Mercury is a liquid. It's very hazardous. And so what happens is you have this tube that's inverted into this pool of mercury. So as the air pushes down on this pool of mercury, it's going to force the mercury up into the tube. So it's going to look sort of like this. The more it pushes down, the more it goes up the tube. And that's how you could tell how much pressure there is. Okay? So from this section, we really want to understand these two definitions, pressure and diffusion, and why if you have a lower pressure, you have a lower boiling point. We also need to understand this table here, how temperature, volume, number of particles, and pressure all affect each other, and we need to be able to make predictions about that. And the last thing we need to know is how a barometer works. So that's everything for section 7.3.1. So you will be taking your quiz on this tomorrow. Thank you very much. Have a nice day.